servers. John can hire people to maintain it and monitor the spikes if they want to scale up or scale down. John can again, and we know that scaling up and down is a tedious business because again, if we have bigger requirements, then we have to purchase more stack of servers, we have to upgrade the capacity, and then the demand is not there, still that resource will be left unused, right? That means here we have to pay for maintenance for its maintenance as well, and servers are costly, they are not cheap devices, right? If there is any better alternative, that is the question of John. So that's why we have cloud computing as a part of the answer. So cloud computing, as we know, is again in cloud computing we go for the power consumption where we pay only for the power units we use and someone else maintains production and supply, right? So cloud computing now, what we have done is, so earlier if we go back almost 2 decades back, then at that time if we had to deploy any application, then we had to purchase a stack of servers, then we had to, and then only we could have deployed the entire website on top of it, correct? Now someone else already has done the entire infrastructure setup, and now they are allowing us to use their infrastructure via internet, and then we simply have to pay a small fee for using their services. That's how they are structured one by one, correct? And that exactly is what cloud computing is. So they are simply allowing us to use the entire infrastructure one by one, which we can go and use it step by step, right? And cloud computing, that's why cloud computing simply makes sure that again, the entire team can focus entirely on the business. They don't have to focus on the generation, or we can say setting up the servers, setting up the entire infrastructure, taking care of its entire maintenance and everything. These all things can be maintained automatically by the help of cloud computing vendors out there, right? And then, the same thing we have discussed here, so the entire infrastructure setup, for example, we have to maintain servers, we have to set up the entire operating system, the networking, applications, storage. So these things, either we have to do this on our own, or these things are already pre-configured, and then we can get the access to these services automatically using the cloud-based platforms. We can easily do that. Just a moment, guys. Now here we have cloud. Now when you talk about cloud computing here, now let's understand how exactly cloud computing has evolved in the going years. First of all, we had grid computing. So now grid computing it simply solved problems with the parallel computing here. So suppose if we have multiple requirements, then we could have simply used multiple parallel computers in like we could have used multiple computing devices parallelly to solve the entire concept of multiple cloud computing solutions, multiple computing requirements, right? And utility now. Then afterwards, we came with the concept of utility computing. Then we came with the concept of utility computing, where the computing services were offered as a metered service. Just like we have a metered service for our electricity consumption, same way there we had metered service, right? And then we came up with the SaaS platform, where it was network-based subscription to application. That means if we want to use any of the services, then we can develop that, and then we can give the solution to our vendors based on the SaaS-based platform, as in software as a service here. And then in terms of cloud computing, then now we have next-gen internet and data center services available from AWS, GCP, Azure, where the entire infrastructure can be configured. We can allow the users to deploy their solutions on our own platform easily. So that now we are not only giving the entire software here, but we are also allowing the users to use our infrastructure and then deploy the solutions accordingly, so that they don't have to take care about the entire setup and configuration of the servers manually at their end. That's the advantage we are giving to them step by step. Right? And then we have Cloud computing evolved with time. Now, first of all, in 1960, John McCarthy introduced the mainstream, we can say mainframe time sharing. Then again, in 1969, it was appended by JCR like later. And then here we have in 1970, we saw the entire concept of virtualization software was launched. When the entire and again in 1991, the World Wide Web was launched in 1991, right? That's when the birth of internet took place. And then in 1997, cloud computing is defined by Professor Ramnath Chulapa. And then we started with the entire concept of cloud computing, where Amazon was the initial, we can say Amazon was the one who launched the entire concept for cloud computing by having EC2 installed here, right? Like we had Elastic Compute Cloud and Simple Storage Services, which was introduced by AWS. And then when Salesforce came into play in with cloud computing in 1999 as well. And then we have in 2017, in 2013, $78 billion worldwide public cloud service market was where the biggest market share was still retained by AWS. And right now, in 2014 itself, we saw a 20% hike in just 1 year in the estimated global cloud computing spending here. And by the end of 2021, we are expected to spend almost 275 billion pounds on cloud computing platforms, especially in these use cases where we have to rely on the cloud computing services, especially in a situation like these. And that's why the entire importance of cloud computing platforms has been increased multifolds, has been increased multifolds. All right. And cloud computing, these are the most commonly cloud computing myths that again, public clouds are not secure. Now, many of them have we can say, has certain reservations on moving the entire infrastructure to cloud. Now, the most common one is public clouds are not made if you're not sure, okay, if the content which are confidential and one content is secure on public cloud or not, then we can deploy them based on the our own private network itself. That means we can create our own isolated network where we can restrict the access of the entire internet to that particular area, and then we can start storing data inside it so that the entire data will be secured with the utmost security possible with multiple levels of encryption that will make sure the entire data is not lost, is not compromised in any use case, right? That exactly is the industry-leading encryption, we can say, and security offered by cloud computing providers, be it Azure or GCP or even Azure, or we can say GCP or Azure platform as well, right? And cloud is not about just virtualization. There are multiple physical devices and integration available that we can use for integrating our entire physical devices into the entire digital platforms it's all together. And again, it can kill jobs because again, cloud itself has generated more than 100,000 jobs globally. That is not a small number. Cloud computing itself has generated more than 100,000 jobs day on globally, and it has increased. And again, it is bound to be increased to almost more than 1 million jobs by the end of this year itself. That means there are now, since majority of the company, or not majority, all the companies they are moving to the cloud platforms. That's why they have a big requirement of someone who has the expertise of making, or we can say, deploying the entire solutions on the cloud computing platforms. That's why they have launched more number of, they have given more number of job opportunities as compared to the other roles that were available in the market previously. And now let's discuss on the in-depth prospects of career in cloud computing. So we know that in terms of market statistics, cloud computing market is bringing a lot of opportunities for a lot of opportunity for the IT professionals. And again, the average salary in US is around $114,000 for cloud computing engineers. And they see a growth rate of almost 121% for job posting between 2017 and 2013 altogether. And the global spend on public cloud services are expected to soar from currently in 2017 it was $153.5 billion, and right now and by the end of 2021 it is going to be almost double up by then Python, Java, Azure, Agile, Puppet, Chef, Ansible, Docker, and VMware. So here we can see the distribution of the skill set employers are looking for whenever they are hiring anyone for the role of cloud engineer. That's a common skill set they are looking for.